Exercise 2.24. A man exerts a 60-pound force F to push a crate onto a truck. A. Express F in terms of components using the coordinate system shown. B. The weight of the crate is 100 pounds. Determine the magnitude of the sum of the forces exerted by the man and the crate's weight. Alright, so the first thing, as always, is writing down the information that the exercise is given to us. So right here I have a force which magnitude is equal to 60, in this case pounds. A. They are asking for the components of the vector F. So for example, if I have this vector is going to have a magnitude in the X or in the I direction, plus or less, that depends on the direction of the vector, a magnitude or a component in the Y direction, which is the same thing as the J direction. Right here we have our coordinate system. The first thing that we have to take into account here is in which cases do we have a positive or a negative component. Right here I have my point 0. Towards this direction I have positive for Y, and towards this direction I have positive for X, which means that towards this direction I have negative, and towards this direction I have negative as well. So this vector F is the resultant vector of a symmetry of two vectors. So right here I have the first vector and the second vector. As you can see, both of them are pointing towards the positive numbers for Y and for X. So I can be sure that the resultant vector is going to have both of the components positive. Now, I do not have any way for me to know the magnitude of the X component, which is this one, nor the Y component, which is this one. But I have the angle. Remember, for when we have, for example, a vector like this, and that vector is generating an angle between the vector and the x-axis, I am able to find the unit vector of that vector. What is a unit vector? Remember that when we're talking about vectors, there are two things that matter to us the most: the direction and the magnitude. For when we are talking about unit vectors, I don't care about the magnitude, because the magnitude of a unit vector is always going to be 1. That is why name. And a unit vector is always represented by a little hat above the letter. So a magnitude of a unit vector is always 1. Why do we use unit vector? Because it allows us to transform vectors, maybe to transform this vector to this position, to this position, to this position, because as I do not care about the magnitude, the only thing that I do care is about the direction. So there are two ways in which we can use, or we can find, the unit vector. The first one is by using the magnitude of the vector. For example, if I have a vector F, I would have the magnitude of the vector F, right? So the unit vector F is going to be equal to the vector F divided by the magnitude of the vector F. This is the first way. The second way is by playing with its angle between the vector and the x-axis. In this case, alpha. So the unit vector of, for example, I'm going to call this vector f. The unit vector of f is going to be as well equal to the cosine of the angle alpha in the I direction, plus or less, that depends on the direction, as always, the sine of the angle alpha in the j direction. All right, so since we have the angle, it allows us to find the unit vector of f. So the unit vector f is going to be equal to the cosine of 20 the I direction plus, and I say plus because this and this, remember, this is pointing towards this direction in which every number is positive, as well in the I direction, plus the sine of as well 20 in the j direction. All right, so this is a number. This represents a number, right? So the cosine of 20 is equal to 0.93. So the unit vector f is equal to 0.9396. Remember, you always have to be aware of the symbol. Why is that? Because this means that the calculator is working in degrees. If I change this to radians, this is going to change our value. I direction plus the sine of 20, 0.3420, the j direction. All right, now we have the unit vector and we have the magnitude. So because of this equation, I am perfectly capable of finding the vector, right? Hence, the vector f is going to be equal to the unit vector multiplied by the magnitude of the vector. That means that the vector f is going to be equal to 0.9396 in the I direction plus 0.3420 in the j direction multiplied by 60. At the end, the vector f is going to be equal to, I want to use cosine of 20 and sine of 20 because since I'm not writing down these numbers, I'm losing, like, this is an error. Okay, you should use as most as decimal numbers as you can. Always use 4, but if I am capable of taking all of them using these two, well, I prefer that. So the sine of 20, the cosine, I need the cosine of 20 multiplied by 60. 56.3815 along the I direction plus 20.5212 on the j direction, and we have our first answer. Oh, all right, do not forget to write down the units. So this is in pounds. Check. B. The weight of the crate is 100 pounds. Determine the magnitude of the sum of the forces exerted by the man and the crate's weight. Alright, the weight of the crate is 100 pounds. Determine the magnitude of the sum of the forces exerted by the man and the crate's weight. Correct? So right here, I'm gonna do it maybe here. Right here we have the force F, right? And they are telling me that the weight the crate is 100 pounds, or the weight is 100 pounds. That means that I'm going to have right here a vector, a force, which is 100 pounds. For example, I'm going to call C. The magnitude of C is going to be 100 pounds. Determine the magnitude of the sum of the forces exerted by the man and the crate's weight. Alright, so I should be able to find this magnitude. Remember, for when you have two different vectors, the summatory between them, graphically speaking, is the connection between this point and this point. Alright, so this is graphically speaking, but we can do it with the components of the vectors. I'm gonna write down once again the vector f. The vector f is 56.3815, the I direction, plus 20.5212, the j direction. This is in pounds. I have the magnitude of C, but I do not have the components of C. But I can get them, right? Because the vector C is pointing towards the center of the Earth. That is why I point it like this. This means that first, the vector C is in the negative direction of Y. That means that the component for Y, or the j direction, is going to be negative. Second, there is no component in the x direction. The component on the x direction is equal to 0. That means that I'm going to have 100 units along the completely j direction, right? That means that the vector of C is 0 units along the I direction minus 100 units along the j direction. This is in pounds. Let me check, because I think that I've made a mistake, so we are going to check it. The magnitude of this vector should be 100, right? So if I try to well, this is not 0. I want to make sure of this. This is not 0. This means that I do not have any component along the x direction. So I should get rid of it for me to not be confused and not to confuse you. The square root of minus 100 squared is equal to 100. So this is correct, because if I write down 0 plus this, alright, this is also correct, but I could be confused as I just did. Actually, I just confused. I'm sorry about that. It is pretty common, though. You have to know that not every exercise is going to be solved as you liked. You have to be confused along the way, and you have to make sure that you're like doing everything correctly. So that is part of the way. So at the end, all I have to do is to find the sum of the forces. So all I have to do is to say, okay, F plus C is going to be equal to what? 56.3815 along the I direction. Let me look for this number, right? This number minus 100. Minus 79.4787 along the J direction. And this is in pounds. Remember, all we have to do is to add the components that are along the same direction. As you can see, this is along the J direction and this as well. So I can add them together. They are asking for the magnitude. Yeah, determine the magnitude, right? So all I have to do is to find the magnitude of F plus C, which is going to be equal to the square root of 56.3815 square plus minus 79.4787 squared is going to be equal to 97.4460 pounds. And this is on our second answer, guys. This is how you can solve this exercise.